Let me start with a very simple first example to see the approach which we are taking in localization. As mentioned before, we have see and act as two important steps. Imagine that a robot is waking up in the morning. It has no clue where it is in the environment. It has a map which consists of 3 pillars here seen. And in reality, the robot wakes up on this position, but because it has no prior information and so far it did not take any measurement, the probability distribution, which describes actually where the robot is in its environment, is equally distributed over all the environment. As you can see here, it has the same knowledge or for all the possible position in the environment. Now, as a first point, the robot takes a picture. This might be with a camera or a laser distance sensor. And with this sensor, it can actually perceive a part of environment, if it's environment. In this case, the robot sees one of the pillars. Now, if the robot knows from the map that there are 3 pillars and it sees one pillar and all the pillars are exactly the same, the robot can at this moment not know where in front of which pillar it is, but it can know that it has to be in front of a pillar. So the probability distribution will change, and you can see here after perception, the robot can infer that it should be in front of a pillar with a certain uncertainty which is given by the distribution, which is similar to a Gaussian distribution in this case. Now, as the next step, the robot will move around. Only by moving around, the robot can actually infer or get more information and improve its belief about the location in the environment. So by moving around, the robot actually can collect information about the wheel movement, but the wheel movement is also a measurement which is uncertain. The robot might probably slip on the ground, or the robot might have wheels which are not exactly the same. So the uncertainty about its position in the environment, so-called the probability distribution, will change, and you can see after a movement, the robot has a new distribution which has some peaks at the position seen here. Now, if the robot will move on without actually taking a picture again from the environment, of course, you can imagine it will get worse and worse, and at one point the robot is again lost and has no clue where it is in its environment. So the robot will then take a second image, a second perception of the environment. So this will result in exactly the same situation as we have seen before, because the robot only sees one pillar because the range of the sensor is limited, and it has in principle no clue to distinguish which pillar it sees. But in this situation, now after the first movement, the robot has prior information, which is actually still seen here, this blue information. And now by fusing the new information coming from the perception with the previous estimate of the position, which is the blue distribution, the robot can infer a new situation where we can clearly see here there is a peak at the current location where the real location of a robot is. So you can see through the see-act cycle, you can improve the robot's belief about its location in the environment. And if you do this properly, the robot can always be localized, at least have a very precise information where roughly it will be in the environment.